Hello, everyone. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and we have an outstanding SD Times Live webinar for you today. It's titled GraphQL Security, Something Old, Something New. And it's going to be a good one. But before we get into it, I just have a couple of brief announcements. First, we'll be taking questions throughout the presentation today. So if our speaker, who is David Ventimiglia right there, you can see him, if he says something that you want to just follow up on right at that time, ask the question. We'll get to it right away. If it's something that can wait till the end, we'll be taking them at the end as well. So we look forward to hearing what you have to say. Secondly, this is being recorded for viewing on demand. It'll be available tomorrow on the sdtimes.com website, so you can watch it over and over again to your heart's content, share with your friends, whatever. And finally, we'll be sharing some engagements with you today here. If you go to the handouts tab periodically, you'll see them pop in. And that's some materials you can take away to further get into the topic. So now here to kick off the program, as I said, is David Ventimiglia. He's the Customer Success Engineer and GraphQL Evangelist at the API company Hasura. David, good to have you with us today, and take it away.
Sounds good. Thanks so much, Dave. Yep, my name is David Ventimiglia. I'm, as Dave said, GraphQL Evangelist and Customer Success Engineer at Hasura. This is not specifically a Hasura talk, but we will be talking about that. This is GraphQL security, something old, something new. That's a bit of a slug, title, but the something old will be sort of bog standard GraphQL security recommendations. Something new will be my hopefully controversial opinions on that subject. So who am I? As I said, I am a physicist, a data scientist, a data engineer, software engineer, and a customer success engineer at Hasura, software technology company that provides developer-focused tooling products, an API company. I am not, however, a cybersecurity expert nor a certified financial planner. Always consult professionals for security and financial advice. Seriously, the subject is GraphQL security, which falls within cybersecurity, which is a serious topic, and it's always prudent to get the benefit of certified experts on that subject. But we have to do what we have to do, and it's worthwhile to know about these things, so we'll forge ahead. So what are we talking about? Well, we're talking about GraphQL security, which naturally involves GraphQL, a bit of a primer on GraphQL. GraphQL is there are GraphQL APIs. GraphQL is a query language designed by Facebook. It has a specification for how that's done. It is built for web services. So hopefully most folks are familiar with microservices, web services, REST web services. GraphQL in some way is a successor to REST. It addresses some of the sort of trade-offs or deficiencies that are involved in REST endpoints. Namely, it provides you a full-blown query language, which REST APIs do not. But that comes with some trade-offs, and it impinges on GraphQL security, as we shall see. But GraphQL, it is a query language. It is organized around it's graph-based, which means that generally you're providing nested GraphQL queries to a server, which is then going to respond with the data that you need. And this is designed for, web applications, mobile apps, web services, things of that nature. But there are schemas. Within schemas, there are types, which are ordered collections of fields or attributes. And then the fields provide you the data. And then these types can relate to each other in a nested fashion. But if you sort of unnest this, it might sound a little familiar. It might sound a little bit like relational databases in SQL. Well, that will become relevant in a second. But in any event, the picture on the right, that just gives you sort of an idiomatic illustration of what a GraphQL query might look like. So on the left, this is a bit of text that a client, computational client, will submit to a GraphQL server somewhere. And it's saying, one of the virtues of GraphQL over REST is being a query language, you can specify exactly what you want in one request. You can get everything that you need and not more than that. and that avoids you don't have to make multiple trips to different REST endpoints in the client and stitch together the things that you need. So in this case, we're asking for, hey, I want the user, I want some attributes, I want their ID, their name, and their email. But then there's this related type, which is addresses, and I want those data, I want the user's addresses, and for those, I want these other fields. And so the client, the consumer of this, can specify exactly what they want, and they'll get the data back on the right as a JSON object. So that's GraphQL itself. Again, it's a language, has a specification, but then there needs to be implementations for that. Historically, to have those implementations, as I was describing earlier to Dave and Jessica, involves writing. You're going to have to write a lot of code. So where Hasura comes in, and we'll see this later, is it saves you writing a lot of that code. But again, GraphQL being an API language for services to communicate across the internet naturally involves security. Security is an unavoidable topic. So what's in this talk related to GraphQL security? I'm adopting sort of what I consider a principled approach to GraphQL security because it's a vast topic and there's lots to talk about, and it's helpful to organize it around a smaller set of principles. You're going to get my opinions on the subject. You're going to get a Hasura demo because I do work for Hasura. This is not explicitly a Hasura talk per se, but it's easiest to illustrate some of these ideas with Hasura. And then we'll summarize at the end. What you're not going to get, because this is just the time just doesn't allow it, is a full-blown talk on cybersecurity, which is a vast and serious subject and does warrant the expertise of certified experts. I think when I considered the topic something old, something new, I was going to talk about REST security, which is kind of the foundation for this. OWASP, which is what's the standards organization, defines principles and practices related to API security. That's a link there. When you get access to these slides, you can access that link. But again, talking about REST security, too vast for this particular talk. Nor can I really go into a comprehensive tooling demo. There's just a galaxy of tools out there, but you will see Hasura, which is a pretty good tool for that. And there are some references at the end that might be useful. So as I said, try to adopt a principled approach to GraphQL security for what that's worth. So what are some of those principles? Well, in this case, I'm drawing from the one book that I've read on the subject, which is a pretty good one, Information and Security, Principles and Practices from Murkoff and Breithaupt. So some key ideas. So first of all, the way they put it is security is about risk management. Again, cybersecurity is a vast subject. You can just pour a ton of attention into it. You sort of get out of it what you put into it, but you also, there are other priorities as well. So one idea is to consider the fact that there are trade-offs involved. You want to get the maximum benefit in terms of in terms of GraphQL security that you can, without pouring in too much effort. So to some degree, that involves like understanding these principles and being engaged and focused on what you're doing. And what I would say is avoiding cargo cults or recipes or rituals, or the way some people put it, security theater, which is to apply security practices just because you're supposed to. You can do that, but that will entail a lot of effort, and you may not be getting the benefit that you hope. Next is know your enemy, know the threats that are in principle arrayed against your APIs. Disclosure, destruction, denial. Disclosure meaning attackers are trying to get you to disclose confidential information. Destruction, the attackers are trying to tamper with the information that you have. And denial would be denying your service, denial of service attacks. Again, so this relates to the previous slide, having a focused approach, engaged approach to GraphQL security. Another principle, this is probably the cornerstone of this talk, is bottom up, or as Murkov and Breithaupt put it, defense in depth as a strategy, which is to say, typically you're building applications in multiple layers or multiple components. Build in security at the foundations and at every level, redundant if you can, within reason, so that at the highest levels, or at the GraphQL level, which would be at the highest level, you can depend on that security, some security already being present and provided by lower levels. And part of that is something I call avoiding identity erasure, which is to say, if you are going to guard against attackers, but at the same time provide a service to legitimate users, you want to be able to know, like, who is my user, who is a legitimate user. You want to have good authentication, and then if you have that, that's part of your contextual information. You want to preserve that all the way through all your layers, all the way through the call stack, so that every layer can make use of that. If you erase that information or you lose that, then you enter a realm where systems just have to trust that the caller is not malicious. But the key is security at every level. Keep it simple. As Murkov and Breithaupt put it, complexity is the enemy of security. Again, cybersecurity is a vast topic. There's just so much that you can talk about, and you can really get lost. So, in addition to getting the benefit of security experts, it's worthwhile to just focus on what are the core principles, and then just keep applying them deliberately and with focus, but repeat. This one, I think a lot of folks will be familiar with, the principle of least privilege. The most secure API is one that does nothing at all. Like, if you're worried about malicious actors, if you put up a web service that doesn't do anything, you can be fairly confident that you're not going to be able to do anything bad, but you're not really going to get much done. But applying this principle is it brings in concepts like whitelisting, like just start with nothing and then provide the bare minimum of what you need, and build from there. So examples of this might be, I think we step out into a related topic that folks might be familiar with, like, say, SQL injection. Often we will hear bromides related to SQL injection about being careful to sanitize your input so that callers don't issue a SQL statement to drop your tables. Well, what I would say is, why is your web service connecting to your database with a user that has the privilege to drop tables? Like, that doesn't make any sense. So just give at every, you're building in security at every level, and at every one of those levels, provide your service and the users of that service just with the bare minimum of what they need and not more. Never trust anyone. So if you can, within the different layers, within the different components of your service, again, rely on that identity information rather than just running sort of in an untrusted fashion code or operations that have been provided to you. Opt in, don't opt out. So again, start with nothing, with very little functionality, and then opt in by adding functionality. Don't just give it carte blanche and then say, oh, well, we want to blacklist this operation. We want to blacklist that operation. Again, sometimes, when left on their own, people tend to make the worst security decisions. These systems are complicated. So just keep it simple and apply the principle of least privilege. These are just some of the principles that are involved, but these are some I wanted to highlight. Okay, so this is, maybe the something old portion, GraphQL security orthodoxy. So, in preparing for this talk, I tried to think, well, what can I offer? If you Google the subject of GraphQL security, you can find a ton of blog articles and webinars and podcasts on the subject. And you will encounter a lot of the same advice. And it's not terrible advice, but they're things like the following. So first, GraphQL servers often will host something like an admin console. And this will combine some number of features. There will be like bona fide administration functionality, like setting properties, setting environment variables, but also performing queries. There will be advice given, which is disable it in production. That's not terrible advice, but there's more to say on that subject, but that's the first thing you'll encounter. Disable schema introspection. So GraphQL, within the spec from Facebook, GraphQL is introspective. What that means is that we said that GraphQL is it's a wide open query language. You can issue a wide variety of different kinds of queries to it, and it should support them. And one of those is introspection queries. You can send a query to GraphQL, and it will disclose all of the types that it offers, all of the fields that are available, how they're all related, and what operations are available. And one security practice is to say, well, that's disclosing too much information. If attackers have that information, they can abuse it. So disable schema introspection so they can't find out. So that's another piece of an old piece of advice. Related to this is query suggestions. Some GraphQL servers, not Hasura, but some GraphQL servers, very helpfully, like even if you've turned off schema introspection, you can issue queries where, if you have a field name, if you have a typo, the server will try to guess what you're trying to do, and it will suggest. So if you say, if you issue a query that asks for email and you spell it EMAAL or something, right? The server will respond and say, do you mean you want EMAIL? And that's one way that attackers can probe and come to understand what services and fields your service offers. So if that's available in your service, you might consider turning that off. This is a big one, and this relates to, remember we talked about know your enemy and what are the kinds of attacks that you face. So one of those attacks is denial. Actually this relates to two, disclosure and denial. So let's see. So GraphQL is a wide open query language, and one of the things that means is in a single operation you can specify everything that you need. Well, if we think about this for a second, we say, well, okay, wait a second. What if a user submits a query which basically says, give me everything, give me all of your data? Naively, a GraphQL server will just very happily say, okay, here you go, and give the user all of the data. So that would potentially disclose everything that's in the database. So that violates disclosure in one operation. And also, more likely, the server and or the database will just come to its knees trying to supply that information, and that'll be a denial of service attack. And this has all happened in one operation. So traditional REST-based approaches like rate limiting, i.e. limiting the rate at which you can submit queries, doesn't necessarily address this. But there are other ways of doing this within GraphQL. There are tools, you can limit the rate that queries come in, but you can limit their duration. As we'll see, GraphQL queries they're nested operations, so you can limit the depth of those queries. You can limit the number of nodes that can be returned. There are ways of computing a complexity score associated with the query in limiting very complex queries so that those don't come in. So this is another piece of old advice, not terrible advice, and there are tools for doing this. Finally, there's whitelisting operations, and this relates back to the subject of the principle of least privilege. So again, GraphQL, like out of the box initially, ab initio gives you a wide open query language where you can ask for almost anything. But another approach is especially like say in production, to then identify a finite set of these are allowed queries. These are the only queries that are actually allowed, and everything else is forbidden. And the way that you would apply that, or one that would apply that, for instance, would be during development, your team would identify the set of queries that it needs for the application to function. Those become part of a whitelist or allowed query list, and then those are the only ones that are available. I say be careful in this application because one of the things, for instance, is that GraphQL queries can take parameters, right? And let's say a parameter is a limit on the number of entries that can be returned. The whitelist or the allow list isn't going to be able to constrain that parameter, and so there are some potential you just have to be careful with how that's applied. Also be careful with something that folks may see, which is automatic persisted queries. Persisted queries is another term for whitelisted operations. Persisted queries are fine. Automatic persisted queries, it's not about security, but it's about performance. It's the recognition that GraphQL queries themselves can be fairly large. And so what we'll do is, it's like caching. The first time a server sees a particular query, it will take that query, it'll cache the query, and then it will dole out a small hash token to the user so that the user can come back later and say, just give me this query with this small name. And that's a way of saving that bandwidth. But because you're automatically persisting any query that comes along, this is not actually whitelisting. So keep that in mind. So that was something old. So now something new. These are my, this is my attempt at some controversial opinions on this subject. So the first thing is, what I've noticed in a lot of talks is a lot of folks neglect to address the distinction between public and private APIs. So what I mean by a public API is one that you make available to the public, either anonymously or to a broad set of users. This is probably most easily illustrated with an example, like say GitHub. GitHub, I think most folks are familiar with that, has APIs. They've got REST APIs, but they also have a GraphQL API. And so long as you're logged in, but that's easy to do, anybody can use that API. And they, GitHub, their API is trying to address a broad class of use cases. So there, it's a wide open API. You can do almost anything. There's not really any whitelisting associated with that. Okay, but a lot of folks are not building public APIs, right? You're building a service, a web service, or a mobile. Maybe you're building a mobile app, in which case, really the only client of your API is yourself, your own developers. Maybe your mobile developers, they're the ones who are using your API. It's not really open to the public, it's a private API. And the security considerations in these two cases they can be quite different. And there are trade-offs involved in that. So that's the first thing is be aware of which case you fall into. If you don't need to offer a public API, then don't provide one. And if you're not providing a public API, then maybe don't act like you are, and in which case some of these security considerations or practices don't become relevant. So relatedly, maybe don't disable console access, or at least the query access. If you've built in security from the bottom up and applied least principal privileges, then the console that it's a web application that users can use, and you'll see this in a second. If that security is there, then the console can't do anything malicious. You can't do anything bad with it anyway. So that's one consideration. Don't disable schema introspection and query suggestions. So disabling schema introspection and query suggestions is, it's the idea of security through obscurity. We're just going to hide the operations that are performed. I've seen some examples where they say, well, let's say we've got this like super secret endpoint, or we've got this secret data. Maybe we're building a new feature into our application. We don't want to disclose it to the public. Schema introspection might reveal that. But my attitude is, well, if the public shouldn't know about it, then don't put it in your API. Conversely, if the public needs to know about it, if they're going to need to know how to use your API. They're going to have access to your documentation, or the information is going to get out anyway. So I don't know that disabling schema introspection really buys you all that much. Even more controversial, don't use GraphQL security, or at least don't rely on GraphQL security. Again, as I said, if you've built security in from the ground up, GraphQL, at the end of the day, GraphQL is just a client of your application. It's another way of posing questions to your application, and it's at the very sort of highest, most superficial level. If you've built in security at every level below that, there's not really much that GraphQL can do to be harmful. Finally, maybe most controversial, don't use GraphQL for private APIs. So what I mean by that is, again, GraphQL it's a query language that, life is about trade-offs. The benefit of GraphQL is that your API developers don't have to design all of the REST endpoints that could possibly serve all of your needs. You can just give this query language, and then users can have at it. The downside is that exposes you, maybe. Well, if you have a private API, i.e., if your API consumers are your own developers, let's say your front-end developers, then use allow lists, use a blessed set of queries, like use GraphQL in development so that UI developers can decide what those queries should be. But once that's been decided, lock those down into with allow list or whitelist, maybe even turn them into REST endpoints or RPCs, and then get on with it. At the end of the day, GraphQL is for people, not for machines. GraphQL is a tool that is helpful for developers to get their job done. But then once that's done, the actual communication between the client and the back end, it could be anything. There's no real benefit to GraphQL in that case. So you might as well turn it into REST endpoints and RPC. And I'm going to get in trouble for saying that as someone who works at a GraphQL company. So while I get set up for the demo, have there been any questions yet? If not, I'm just going to forge ahead. Okay, so, and I apologize for speaking so fast, but time is limited. So what is Hasura? So this is a Hasura demo. I said that Hasura is a tool that my company provides so that you don't have to write all that code to create that API. We have an open source version, which is free. Anybody can use it for free. You can write it on your own hardware, your own infrastructure. But then again, we do provide a premium product which has additional features, and we also host that product on Hasura Cloud, which is what I'll be showing you here. And what Hasura does is it's a service. You point it at a relational database. You give it a connection string to a database. It will introspect that database, identify all the tables that are within it, and it gives you the ability to present all of those tables as GraphQL types. It basically generates that GraphQL API for you so that you don't have to write it yourself. This here is the UI for Hasura Cloud, which is our cloud offering. So this is how you can get Hasura going without running it on your own infrastructure. And from that, this tab here shows you Hasura console. So this is an example of that console, which I had said, GraphQL security orthodoxy will tell you to disable in production. Not terrible advice, but as I said, it may not buy you that much in terms of disabling. But this is what the console looks like for Hasura. It has a number of tabs across the top. Most important, we'll come to the data tab. And what we're saying here is, let's just start in the top left. Right, okay. So, and some of this I've set up beforehand. But what we've done here is I've said, okay, this instance of Hasura is connected to a database through this. There's an environment variable that I provided. It's not important how that works right now, but that environment variable has a connection string which connects this instance of Hasura to a Postgres database. So where's that database? That database is running on another cloud service. This is Railway. It's kind of like Heroku. They just offer, free databases that you can use for a limited time, and it's a convenient way to get started. And you can see within here, they give you the connection information. So that information has been provided to Hasura. If you'll allow me, I'll switch over to something even more horrifying, which is a SQL client. So this is a SQL client connected to that database. You can see we're connected to Railway, and look at the tables that are in here. Okay, so what I've set up is there are really 4 tables for this demo. There's an account table, has accounts. From account. So we have fictitious people. There's the name, created at, updated at. There's an ID field. So I'll take this as a moment to make an aside. This, I think, illustrates building in security from the ground up. So we haven't even talked about GraphQL security yet in this particular demo, but as you can see, the identifier or the primary key for these data are UUIDs. That's this alphanumeric string right here. So why is that relevant? Well, one common attack that will occur is attackers will try to guess or enumerate other data within your application. So if they see that there's an account with an ID number 10, they can guess that you have monotonically increasing numeric identifiers. If there's an account number 10, there's probably an account number 11. They can just say, one by one, they can say, give me account number 11, give me account number 12, give me account number 13, and they can ask for all your data if you don't have any other measures in place. When you have basically an unguessable alphanumeric string as your identifier, there's no way that they can guess what the other identifiers are. So this is an example of, and I can provide more information on this subject. This is a long-standing practice in database security, but this is building in security at the database level so that that security is then a foundation for all the levels above it, including GraphQL. Anyway, so there's an account table. There is a product table, and I think it's food items. Right, so there's, these are grocery items. And then there's an order table, which I won't dwell on. There's the usual order table and order detail, right? So accounts represent customers. Customers or accounts have orders. And then associated with orders are some number of items that belong to that order. And then those items relate to products. What are the items that are being purchased? So that's the database side of things. So those are those 4 tables, and then there's a view that's involved as well. We go back to Hasura. Ignore these. So it's giving you a list of all the schema that are available. Ignore these timescale DB schema. But there's this public schema, right? That's the schema that has all of these tables. You can see the account table, the order table, the order detail, the product table. There's also some functions that I added as well, but you can ignore those. So look at account, and again, what you're seeing here is this is just the admin view. This is not what consumers of your API will encounter. But you can see that there are all of these data. There's all these account customers. We've got a product. There are all of these products that we just saw, and then there are order entries, which really just have the identifiers that tie things together, and order details. Okay, so how do we start providing some GraphQL security? Well, let's first we'll do we'll run through the list of orthodox security practices. And how do we apply these in Hasura, keeping in mind that there are ways to apply these principles in other tools, but this demo is about how Hasura applies them. And one virtue of Hasura is that it brings all of these together in one place. I think you'll find that if you try to build GraphQL servers or applications and build in GraphQL security, you really have to start adopting like an a la carte approach where you grope around for this library that provides, GraphQL depth limiting, and then you find another library that provides rate limiting, and you stitch it all together. One of the virtues of Hasura, it just brings it all together in one place. So we will go to, well, first of all, let me just show you. So having done that, these tooltips annoyingly pop up. This is, Now this is a tab. This is the API tab within Hasura's admin, and this is the thing that people really want to stress that they want you to disable. And what this is just a query application. This is just a convenient way to submit these GraphQL queries to your server, right? So you can say, well, you can see all of the types that have been provided as part of this this API on the right. You can it's generated documentation for all of these types. All of this has been generated automatically. No code was written for this to occur. So that's one of the nice features of GraphQL, or of Hasura. You say, well, I want accounts, I want the ID, I want the name, and you know, I could apply a limit. I could say I want just 10 of them, and we'll run that query, and provided the database doesn't fall over, great, we got all of those. But I don't have to supply a limit, right? What if I said, well, give me everything? Well, this would be an example of disclosure or denial. Now there are only 1,000 accounts in this database, and the database had no trouble providing those. But if there were 10 million, that would be a genuine problem. So how do we turn that off? Well, first of all, one of the things I'm going to do is, so one aspect of security is, as I said, we don't want to perform identity erasure. We want to identify who the user is and then not forget that. Identifying who the user is the province of authentication. Authentication can be done within Hasura. I won't exactly show how that's done because that would just take us too far afield. But that's where you basically stipulate, this is who I am as the caller, and you provide some means of verifying that. In this case, for demo purposes, I'm just going to say that I am a user. So, because if I have an admin, I can do anything. But let's say that I am identified as a user. That's my general role that I play, and then I'm specifying through a header that I am this particular user. This is an ID that I pulled out from some particular user. And right off the bat, it says, "Oh, query is not allowed." That's because I've turned off introspection for non-admin users, and we can see that if we go to right. So the global user for anybody who is not the admin, schema introspection, there is no schema introspection provided, right? So that's been turned off. So that's limited. Let's go further. Now we can actually run this query. Okay, query is not allowed. Great. So what we'll do is to security. We'll say, okay, here's what we need to do. We need to say, okay, for the user, they are allowed to perform some operations, but what we're going to say is, well, let's limit. We need to set a global depth limit first. Global. We will enable, okay. We'll enable a node limit, and we'll say, well, you can only get, let's say 5 nodes. And for depth limiting, we will say, well, we've got 4 tables, 4 nested levels. We've got account, and then belonging to account, we have order, and then belonging to order, we have order detail, and then associated with order detail, there are products. That's 4. So the depth of your GraphQL queries should be 4 and no more. And I can show you this in a second, but there is the possibility of, without depth limits, of doing recursive queries where you say, well, give me account. For that account, give me the orders. For that order, give me all of the order details. And for each of those order details, give me the orders, and then give me the accounts, and back and forth, and you can really blow up the server that way. So we'll pose let me do that again. Depth limit is 4. Node limit is 5, say. We will do a rate limit. You can do rate limiting. You can say, well, let's say you can't do more than 10 queries per minute. And that will be enough for now. We'll save those settings. So that's global limits for any user. Now we'll say, well, there's this user role who has even more stringent limits. We will say, we'll still have a depth limit of 4, but we'll do a node limit of 3, and we'll do a rate limit of, they can only do 5 per minute. So I'll go back to the API, and we'll say, okay, so as, first of all, if we're admin, again, we can do perform a query. Let's try to trigger some of these depth limits. So we'll say, well, what we're going to do is we're going to say for we want count, and as you can see, it's doing query suggestions, and that's part of GraphQL's introspection abilities. And again, that's something that as a recommended practice, folks want you to turn off, but it's super useful for developers. And then again, once you've turned your public API into a private API, turning it off really is not all that relevant. But we say for accounts, we want orders, right? So we've gone 1 level, that's 2 levels. We want order details, right? And then for the order details, we want product. For the account, we'll say we want ID and account name. For order details, we want, let's say we want the units, that's the number of items purchased. Products, we'll say that we want name of the product and the price. And we will, there's no limit on the number of items that can be returned. So we get, right. Okay. But now let's try to write a recursive query. We'll say, well, so from product, we want to go back to order details and get order details. And then from order details, we want to go back to order. So the way to think of this is we've gone down the hierarchy from order to from account to orders, from orders to order details, from order details to product. Now we're going back up. Now this isn't really useful, but this is a way an attacker might consider doing this as a way to try to blow up or create a denial of service for the system. So, so it's thinking. Now I'm admin, so it's probably letting me do this anyway. But as we'll see, when I change my user to user, it should be disallowed. So in fact, we'll do that now. Okay. See, it's already, so this is an example of a denial of service. So what we want to do is say, well, let's user. And again, as soon as I become user, since I've disabled schema introspection, that's not available. We'll run this. Okay, there we go. It says query is not allowed, and that's because of the depth limit. Now let's see if I can rescue this query. What we'll do is we've said that we allow 4 levels: account, orders, order details, and product. So what we'll do is we will get rid of order details. This pop-up is coming through. And why is it not allowing this? Okay. Security. You said user is allowed. Okay. All right. Well, the demo gods are not smiling upon me, but the idea is that it would limit the query for that user. Yeah. Not sure why that's not behaving the way it should, but again, the principle is that with this enabled, because what's happening is it's not allowing any query from this particular user. But I'll sort that out. And all of this, by the way, all of this will be available as runnable code associated with the GitHub repository. That's part of this webinar. And I'll make sure that this functions the way that it's supposed to in that code. So we'll go back to admin. We know that we can run queries that way. And what I will show you next is, there's not enough time really to show you all of the GraphQL security features that are available within Hasura, but I do want to show you, because one of the most valuable ones, in my opinion, is allow list. I talked about turning your GraphQL, your wide open GraphQL query API into something more limited, applying allow list so that there's just a blessed set of queries. So the way you do this in Hasura, there are other tools that allow you to do this outside of Hasura, but the way you do this in Hasura, there are a couple of ways of doing this, but in the monitoring tab, if you go to allow lists, so the project will keep the application will keep, it'll remember a list of queries that you have performed, and it will offer those as queries that you can select. So if I say, well, let's see from here what we have. Okay, we'll go here. There we go. We'll say, okay, 4 minutes ago we ran this query called my query, which was to get all of these data. So we'll choose this one, and we'll add it to allow list. So that is, once that's done, once you've enabled allow lists, then that would be the only query that is available to be applied. So that's an example of applying the principle of least privilege. The final thing I'll show you related to this, I talked about the possibility of turning GraphQL queries into RESTful endpoints. If we go back to the API tab and under REST here, you can, this is done under, that's right, so here. So we'll say, what we'll do is we'll say, okay, this query, right, that we issued earlier, which does actually run, we will turn this into a RESTful endpoint. So we'll say this is, we'll call this account order details. Give it a name. We'll call it. I have a query setups already for this, so we'll call this REST account order details. Say that you can perform GET operations with this endpoint, and we'll call it good. Because the server is newer than what you loaded in the console, the metadata has to be refetched. Sure, demo gods will fetch the metadata. And we'll try this one more time, and if not, we'll say, okay, great. So what this has done is this has created a RESTful endpoint called REST account order details, which runs that GraphQL query for you. So now we can go over to this is a REST client within Emacs. We can say that we are the admin, and I'm going to get the order details. And here it's saying that the node limit has been exceeded. Try that again. What we'll go over here is we'll say, go to security. That would be this global limit. It's the node limit that's clobbering us. We will say, we'll bump that up. We'll say you can get, well, we'll just disable it. How about that? Probably the safest thing. Okay. Let's see it. Untitled query root. Okay. I don't know what's going on there. I'll fix that. Okay. So that's, sorry about that. I'll just, I will give you a tour of some of the other features within Hasura that allow you to apply some of these measures. So if we go over to the data tab, on every one of these types that are exposed through Hasura as a type, there's this permissions tab. And so what we can say is, well, for different kinds of users, like say there's the admin, but we can also say user. We can have something called read-only if we wanted. We can specify whether that users of that type are allowed to perform the usual insert, select, update, delete operations, and we can get more fine-grained if we like. So like we can say, well, users a user who's not an admin, they should be able to access any account. They should really only be able to access their own account, and that's it. So we will say, well, there's a custom check. Custom check will say, and so the Hasura UI has a mini domain language for doing this. We'll say, we will say that the ID column or the ID attribute on the account has to be equal to. And so the identifier for the user will come into the application, into the API, either through a header, request header. So there's X Hasura role, and there's X Hasura user ID. Now, if you, of course, you have authentication set up, so the user will, in a real application, use the call will specify an API token, a refresh token, an identification token, and then that will go to a web service which will verify that this user is who they say they are, so they can't just spoof themselves, or they will supply a JSON web token which will have this information within it, and then that can be verified for the server. But let's suppose that that's happened. So then this Hasura user ID becomes available to Hasura internally within it, and you can use this in these custom checks. So what we're saying is, users can only perform queries that select account rows where the ID attribute of the row, which again, that is the account ID, matches X Hasura user ID, which is their account ID. And we'll say, we will say that they have access to their ID because they know their ID and they have their name, but they don't have access to these other fields. And save these permissions. And then we can say, and they don't have access to insert, update, or delete because users don't insert themselves, right? An admin does that. And then likewise, we can go to order. We can set permissions on this. We can say, well, users only have the ability to see, say with custom checks, and we will say the account ID on the order field, it's called account ID, equals X Hasura user ID, and they can only see the ID and the account ID. And so what this means is now users can, of course, they can only access their own account, and they can only access their own orders. And you can go up and down through the stack, and you can apply these permissions to everything. So again, this is the principle of building in security like within the application at every level, and then that becomes available all the way through the stack. There's lots more for the aspects of the demo that that didn't work. It's funny. I had all of those things set up, and then I was like, wow, why don't I just like demo creating them? So I deleted them all, and now try to put them back, and they don't work. So I'll figure that out. But let me take a breather now, because I think we're coming up close to the end, and ask any feedback or questions that have popped up. Happy to answer those while I switch back over to my slides, because really we're coming into the summary.
Yeah.
Cybersecurity is a vast. Go, fire away.
David, I just wanted to jump in. We don't have any questions at this point, which to me says that that was an excellent presentation. So,
oh, thanks. Very kind, very kind. I again apologize for the aspects that don't work, and I apologize for talking so fast.
Yeah.
I'm just trying to cram it all.
So we have about a minute and a half to go before we're out of time. So if you want to do your a quick summary and final takeaways for our attendees, that would be gret.
Absolutely. Yep. Like I said, cybersecurity is a vast topic. Again, consult experts, but again, we have to get on with our day and get our work done. So it's worthwhile to know about these different aspects. So focus, take it seriously, tame the vastness with a principled approach that kind of organizes and simplifies things. Do the easy things. That's for GraphQL. That's the GraphQL orthodoxy. But only do it. Those are things like disabling introspection. Sure, you can do that, but don't rely on that. Like really focus and engage, and really build in that security at every level. There's probably a ton of good resources on the subject. This book by Murkov and Breithaupt is the only one that I've read on the subject, so I think it's pretty good. And there's also, if you're going to use GraphQL, read the GraphQL spec. There's some eye-opening things in there. This talk, the slides are available in a GitHub repo. So these are some of the other tools besides Hasura out there that will do things that will help you out. Like SOFA will allow you to create RESTful endpoints. There's a tool. A lot of these are tools for Node.js. You can do whitelisting. You can build an authorization into your app. You can limit queries based on complexity. But at the end of the day, you can always just come back to Hasura, which does everything except for query complexity. And that's it. This QR code, which provides a link to the GitHub repo that has these slides, but that information will be available to you elsewhere as well. And that's all I've got.
Excellent. Well, thank you so much, David Ventimiglia, Customer Success Engineer and a GraphQL evangelist at Hasura. Appreciate your time. And of course, thank you to Hasura for sponsoring today's event. And thank you to our attendees who spent quite a bit of time this afternoon with us. We certainly appreciate you being with us here today. So until next time, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.
Thanks, Dave. Thanks, folks.
Dave.
Bye.